Good morning, everyone. First of all, I would like to express my sincere gratitude to the organizers for this valuable scientific opportunity. I'm also honored to welcome the distinguished professors, researchers, and respected audience. It's a pleasure for me to present my contribution entitled Urban Noise Pollution Acoustic Analysis of the Square District in Constantine and Mitigation Strategies. So, through this presentation, I will discuss the issue of urban noise pollution in the Square District of Constantine by analyzing the acoustic environment and identifying the main sources of noise disturbance. I will also present possible mitigation strategies that could contribute to improve acoustic comfort and urban environmental quality. I hope that this presentation will encourage constructive discussion and contribute to ongoing research on sustainable and healthier urban environment. So, architectural and environmental acoustics is now an essential interdisciplinary field at the intersection of architecture, urban planning, and public health. It integrates both the physical properties of sound and human perception. In sustainable development perspective, outdoor acoustic conditions have become major public health issue. In Algeria, empirical studies remain limited despite rapid urbanization and increasing traffic. The study addressed the data on dense commercial districts by evaluating noise pollution in the Square District. For the objectives of this study, the first aim is to assess noise levels through in-city measurements. Secondly, compare noise pollution between weekday and weekend. Generate an indicative noise map using noise tools. Simulate the effect of continuous vegetative barrier. Propose and suggest practical and sustainable mitigation strategies. This study adopts a quantitative approach based exclusively on in-city acoustic measurements. The measurements were carried out using simple sound level meter to record the instantaneous sound pressure level. The methodological protocol was structured as follows. Measurement points. 4 fixed points were selected in the Square District in Limengli, representing different levels of noise exposure. The first point is the main road access. The second point represents the commercial intersection, and the third point represents adjacent pedestrian area. The fourth point is the buffer zone. So the measurement period, the campaign was conducted over 3 days, Tuesday and Thursday and Saturday. Time slots recording were performed during peak hours from 8 hours to 9 and from 18 to 19 and off-peak hours from 13 to 14. Multiple readings were taken at each point and time period to ensure representative values. Data processing and mapping. All collected data were processed and mapped using the online tool noise tools, which generated indicative noise maps and allowed clear visualization of spatial temporal distribution of sound levels within the district. The case study, the Square District located in Limengli constitutes major commercial hub at the heart of Constantine. It's characterized by high concentration of commercial activities and services, intense daily road traffic, and significant pedestrian flows. So the urban morphology of this district, with its relatively narrow streets lined with medium-height buildings, creates a pronounced urban canyon effect that traps and reflected sound waves, thereby amplifying ambient noise levels. As a result, users including shopkeepers, customers, and nearby residents are continuously exposed to high levels of noise generated by road traffic, commercial activities, deliveries, races, and pedestrian movements. This dense and dynamic environment makes the Square District particularly relevant case study for analyzing noise pollution in highly active commercial urban areas in Nigeria. The acoustic measurements results. The in-city acoustic measurements were carried out over 2 days, weekday, Monday, and weekend day, Saturday. This distribution highlights the evolution of noise pollution between typical weekday and day characterized by high commercial and pedestrian activity. The recording of the instantaneous sound pressure level were conducted every hour at 4 measurements points covering peak period and off-peak hours. The obtained results reveal very high noise levels through the Square District, with significantly greater noise pollution observed on Saturday. The noise mapping, the hourly data from both measurements day, were integrated into the acoustic mapping tool in order to produce detailed spatial representation of noise distribution within the study area. For each day, the sound pressure levels recorded at the 4 measurement points were entered on an hourly basis, allowing the analysis of 3 representative urban activity periods: morning, midday, and evening. This approach highlights the spatial temporal variations in noise dependent on the intensity of urban activities, particularly road traffic and movement and commercial activity. The resulting noise maps are presented below in chronological and comparative organization between the 2 measurement days. So the figure 2 represents noise map during Monday from 8 to 9 hours. Figure 3 presents noise map during the hour of from 13 to 14, and the third noise map represents Monday from 13 to 14. So this is the Monday and off-peak hours. This is the present figures present the Saturday day. Okay, so the simulation with vegetation barriers. A continuous vegetation barrier was simulated around the Square District using noise tool to evaluate its effectiveness in reducing urban noise pollution. The barrier consists of oriental plain trees selected for their dense foliage and high acoustic absorption coefficient. The vegetation belt acts as natural acoustic buffer between traffic, commercial noise sources, and pedestrian areas. The simulation results showed significant reduction in noise levels, demonstrating the effectiveness of green infrastructure in improving acoustic comfort in dense commercial districts, as shown in the present table and in the present figure. The discussion of the acoustic measurements confirm the presence of chronic and intense noise pollution in the Square District. The average noise levels reached 71.3 decibel on Thursday and 76.8 decibel on Saturday, exceeding the recommended limits. Noise pollution is more severe during weekends due to increased traffic, pedestrian density, and commercial activities. The urban canyon effect amplifies and traps sound between buildings, maintain high noise levels even during off-peak periods. Prolonged exposure to these levels may cause stress, sleep disorders, auditory, and reduced cognitive parameters. The vegetation barrier stimulation using the Plantius orientalis reduced noise levels by an average of from 7 to 8 decibel, especially near road access and intersections. The study highlights the importance of integrating green infrastructure and urban acoustic planning to improve environmental quality in dense commercial districts. So, in conclusion, we can say that the study confirmed the presence of chronic and intense noise pollution in the square districts of Ali Minjli. Average noise levels reached 71.3 on weekdays and 76 on weekend, exceeding the Algerian standards. Weekend commercial and pedestrian activity significantly increase noise levels and reinforce the urban canyon effect. High noise exposure may negatively affect health, comforts, and economic productivity within the district. The simulation using vegetation barrier of Plantius orientalis achieved significant noise reduction. The results demonstrate the effectiveness of nature-based and sustainable solutions for improving urban acoustic comfort. So this study highlights the importance of integrating urban acoustics, noise mapping, and green infrastructure into future urban planning strategies in Algeria. Thank you for your kind attention, and I wish you all successful and enriching conference. If you have any question, don't hesitate so if you have any question, don't hesitate to contact me. Thank you for all your efforts. Bye bye.